Now let's continue this. We have letter D, E, F. Same lang yung ating given. So we have the integral of e to the x minus 3 raised to 3x minus 1 from negative 1 to 7. Okay. So, una sa lahat, if you're trying to think of this as integrating and then using your definite integral, so don't attempt to do that kasi hindi mo to masosolve using that kind of method, no? This one is a little different than the one we discussed, yung mga basic integration procedures. So, ang kailangan natin dito is ma-identify yung gagawin natin through Riemann sums. So, since aware naman kayo na kailangan natin itong i-graph, though minsan hindi mo na talaga kailangan siyang i-graph kasi pwede mo naman na hanapin na lang yung mga values of x's from negative 1 to 7 using this n equals 4. But to visualize this more accurately, I'll be using a graphing calculator to graph this function. Okay, so the graph of this function almost looks like this, no? And then when we try to do this left endpoint, for example, this one is the negative 1 portion. So you start with this, okay, and then you draw squares. What you have to do is to make 4 partitions of that. So 1, let's say this one is yung 7, and then we have to make 4 partitions from that. So gawa lang kayo ng 4, and then you do the left endpoint. So this one, left endpoint. So pababa naman siya, no? And then, how about this one? So, hindi nyo siya extend dun sa dulo kasi we're using left endpoint dito, no? So, siya, underestimated. But anyway, so this is your Riemann sum for the left endpoint. And let's compute na lang siguro for the values. So, yung ating norm is delta x, which is equal to 7 minus negative 1 becomes positive 1 over 4. And this is 8 over 4, kaya magiging 2. So therefore, yung ating interval from negative 1 to the next value would be negative 1 plus 2. So therefore, kung mag-start ako sa, let's say, yung ating a, diba yung a natin is negative 1? So yung ating a plus 2 would be equal to positive 1. And then yung ating a plus, yung a plus 4 naman, kasi yun yung sunod natin na interval dito, would be positive 3. And then the next one is 6. So we have 5. Okay. And then I think that's all. Kasi this one is negative 1. This one becomes positive 1. Though hindi siya kitang-kita dito sa graph na gano'n siya, no? 3 and then 5. So hopefully ay nag-guess nyo kung saan to kinuha, no? It's just that you add mula dun sa left endpoint itong delta x. So sunod-sunod lang yan. So una plus 2 lang. So 1. And then you add 2 again. So magiging 3. And then you add 2. So 5. So ganon yung ating magiging way para mahanap natin yung mga values na kailangan for left endpoint. And then, siguro kung kailangan pa natin hanapin yung pinakadulo dito, so you just have to add this another 2 from this. And then, dapat kailangan makuha nyo ngayon is yung 7, which is the upper endpoint or the upper limit of your integration limits. Okay, so anyway, so meron na tayong values na to, and then remember, pag left endpoint, ang kailangan lang natin is itong una, pangalawa, pangatlo, and pangapat. So ito, hindi natin siya kailangan. That's why it is always underestimated or almost underestimated kapag meron tayong graph going downwards and then you start with the left endpoint. Now let's start solving for the Riemann sum. So meron tayong area using the left endpoint. This is equal to your f of x, which is negative 1. So we have f of negative 1 times natin sa ating delta x, which is 2. So we have delta x dito, di ba? Ang gagawin ko is ilalabas ko lahat ng delta x kasi yun lang naman yung multiplier natin sa lahat ng f ng function natin. So sunod is f of 1 plus f of 3, and then f of 5. And then delta x. Okay? Pwedeng lagyan nyo rin ng ganyan para ma-indicate na siya yung norm. So, a sub L would be, ano ba yung f of negative 1? So, you just have to substitute substitute yung negative 1 dito sa ating expression. So that is e raised to negative 1. So from this, f of negative 1 is equal to e raised to negative 1 minus 3 times raised to 3 times negative 1 minus 1, which is equal to 1 over e, and then I think this will be minus 3 raised to negative 3 minus 1 would be negative 4. Okay? So, pwede rin tong e raised to negative 1. So, ito yung ating values for the first one, for the first term here, no? So, we have, you can just write 1 over e minus 3 raised to negative 4, and then yung pangalawa naman is, so you add, gawin mo ulit siya for f of positive 1, so this is e minus, I think that will be 3 times, raised to 3 minus 1 would be squared. Okay, so that is e squared minus, e minus 3 squared. Okay, and then for f of 3, so we have e raised to e cubed minus 3 raised to 9 minus 1, which gives us e cubed minus 3 raised to 8. Okay, so kopyahin mo lang yun again for this one. And then finally, for f of 5, actually mali pala yung tapat-tapat ko pero never mind. Dito dapat ito nakatapat. Anyway, e to the 5th minus 3 raised to 15 minus 1. So this becomes e to the 5th minus 3 raised to 14. And then don't forget to multiply all of this by the norm, which is positive 2. Yung positive naman talaga lagi yung norm eh. So with this, you can compute for the area using the left endpoint. And you should be able to get negative 9. Negative, ito medyo malaki-laki to kasi kita nyo naman yung graph, napaka extending to downwards, no? Negative 9,578,734.855. So don't forget the unit is square units. Okay, so ito yung ating sagot for this one using the left endpoint. So ganun lang yun, evaluate nyo lang siya and then multiply to the norm, and then you're done with the Riemann sum. Now you might be thinking, bakit yung area natin is negative, and pagka kasi sa real life wala naman tayong area na negative. Now okay lang yun for this case kasi ito kasi is signed area yung tinutukoy natin dito. So pag signed area tong mga to, like dun sa ating mga pinag-usapan later on sa definite integral. So, itong mga to, pag ang area natin is above the curve, kasi 'di ba dapat under the curve natin pinag-uusapan nito. Pero if it's above the curve, then expect natin na yung area would be negative in that case. So, with this, okay lang na maging negative naman yung area. Pero syempre, if we're talking about the area na nasa geometry, sa mga ganun, so hindi dapat nagda-negative yung mga area natin kasi parang physical quantity na yun nung mismong real life scenario. Now anyway, so let's proceed naman using the right endpoint. Though hindi na siya mababago ng sobrang laki dito. But if I'll be using the right endpoint to draw yung ating mga rectangles dito, so mapapansin nyo, I'll start with the right endpoint. So this is yung 7. So 7 is right here, around here now. So ganito siya. Ibahin natin ang kulay. So if I start with the right endpoint, dito siya, no? Okay? And then project ko siya to the left. Okay? Ganyan. And then this one. Okay? And then this one. And then, hindi ko na, sorry. So, eto. Okay. So, with this, ito yung ating right endpoint na sinasabi. So, it has to extend pa further into this portion. Okay. So, kung mapansin nyo ngayon na yung ating right endpoint is much larger than our left endpoint. And it has to be expected in this case. So, gagawin lang natin is i-modify na lang natin siguro itong sagot. I'll just copy the yung ating sagot muna dito. So, A sub L. And I'll be removing this. Okay? So, gagawin natin ngayon na right endpoint itong ating solution. So, pwede natin itong sabihin na this one is the right endpoint. Okay? And then, syempre, if this is the right endpoint, then hindi natin gagamitin yung negative 1. Instead, we'll be using 7 here. So, pwede natin itong burahin, and then we'll be using f of 7. So, you can just remove this, yung first, natin for f of negative 1. So, we need to find first your f of 7, no, to be able to use it. So, that is e to the 7 minus 3 raised to 21, okay? And then minus 1, so this becomes e raised to 7 minus 3 raised to 20. So, this becomes e raised to 7 minus 3 raised to 20. Okay? So, expect nyo na mas liliit siya in terms of your value, or increase siya in terms of the magnitude naman. So, solve nyo lang yan, and you should be able to get something like, from the expression itself, yung negative 349,157,2,672, and then you multiply it to 2, so you should be able to get negative 69,698, 3145344. So basically, this is ilan ba to? 1, 2, 3. So we have a billion, 6,983,145,344, and that is square units. So kung mapapansin nyo, sobrang laki ng atin, no? And we can just box this as your final answer for the right endpoint. Okay, so that is what you do for the right endpoint. And napakalaki talaga niyan, kasi kung makita niyo actual graph niyan, talagang babang-baba yung ating graph. So, if you're asked to find the average, so you just take the average of your left endpoint and the right endpoint. So you should be able to get your a average, which also translate to the trapezoidal rule if you try to apply that. So divide mo lang to sa 2, and you should be able to get something like negative 349. You think that will be 6362040. Okay, so siguro pag may mali kayo, just tell me if iba yung nakuha yung sagot dito. Kasi mahaba-haba tong digits nito eh. So this is your average area using the average of left and right, or the trapezoidal rule. Kasi again, same lang sila. Now, kung mapansin nyo, parang dinivide lang natin sa tutong area, right? Kasi this one is really large compared to this left area, no? Kaya kung mapansin nyo, parang ito lang yung dinivide natin sa 2. But anyway, if we try to make a trapezoidal rule here, so alam naman natin na what you have to do is to connect the points from the curves itself. So kung halimbawa gagawa tayo ng trapezoidal rule dito, let's try doing one. So this one, ito yung left endpoint mo. Let's make it more vivid. So halimbawa ito yung left endpoint mo. So using the average, or the trapezoidal rule, you connect it to the second point here, okay? And then the third one, okay? Medyo pangit yun. Okay, and then ito last. Wait lang And then 7 would be something like here. So connect mo ulit siya dito. Okay, so you have 1, 2, 3, and then 4 partitions. So 1, 2, 3, 4. Okay, so nakita nyo ba yung parang trapezoid na nagagawa natin dito? Okay, so this only means na yun na yung ating average area, which is much more accurate than using your right endpoint or your left endpoint. Kasi yung left endpoint medyo sobrang bababa pa niya, yung right endpoint naman sobrang taas niya na, no? So you have to take the average of that para mas maging accurate. Pero syempre, the problem will still ask you, palimbawa, tinatanong is, ano ba yung average? Siyempre, average kukunin mo. Pero if it's just your right endpoint, then right endpoint lang hahanapin. No need to find your left or average. Okay, so I think we're so much done with this problem. So let's proceed to the next one. Now for the next one, we have sine x, cosine 4x, and then integrated from 0 to pi, where of course we'll be using the left, right, and the average of these endpoints. So it is partitioned into 6 from 0 to pi, and then we have to compute for the norm. Again, that is yung difference mo lagi sa upper and lower limits of integration. So that is pi minus 0 over 6, which gives us pi over 6. Okay, so if you start with a being equal to 0, so a plus pi over 6, which is equal to pi over 6, then yung next term, so we have to expect na meron tayong 7 dito, no? That is 6 plus 1. So a plus, so if we have pi over 6, and then sunod naman is 2 pi over 6, okay, so or pi over 3, so this gives you your pi over 3. Okay, so a plus, yung sunod naman is something like pi over 3 plus pi over 6, so this gives us your value, which is pi over 2. So that is pi over 2. So ito na ngayon is pi over 2. Now we proceed further, so that is pi over 2 plus pi over 6. So this should give you a value of 2/3 pi. So 2/3 pi din naman to, and then we still have 1, 2, 3, 4, 5. We still have 2. So yung sunod natin is 5 over 6 pi. Okay, so this is 5 over 6 pi. And then finally, your b, actually b na yun eh. So this is equal to pi. Okay, so yun na yun. From 0 to pi, and then we have 6 partitions. Ito yung mga endpoints nun, ng mga rectangles na yun. So, for the area of the left, the Riemann sum on the left. So, pwede kayong mag-draw dito para ma-visualize. So, from the left endpoint, so, gawin ko is parang i-maximize natin dito, no? Yung drawing. So, parang ganyan siya, no? So, from the left endpoint, you start here. And then, kailangan kasi, di ba, pi to, so around 3.14 yon. So, basically, kung ito yung natin 1, I think this is 1, 2, and then, probably this is your 3. So, di siya sobrang accurate ang drawing ko, but, we have 1. Sige, i-redraw natin tong curve. So we have this one, and then parang ganyan, no? So we have here yung 0 natin, no? And then yung first unit mo, okay? And then second unit, and then yung third unit somewhere here. So if that's the case, then yung first partition mo would be this one, 0, and then that is pi over 6. And kung i-equate nyo yung pi over 6 into decimal, that is around 0.523. So kakalahatiin natin yung 1 unit dito. So your first is 0. So pag ganun, pag 0, straight line lang siya, no? So kung dito ko gagawin siya, straight line lang siya, no? Ganyan lang siya. Okay? So how about for the next one? So sabi, you have to project that to your next na pi over 6. Pi over 6 units. So the pi over 3 is equal to 1.047. So somewhere here, dyan ka mag-i-stop, no? Pero how do we project that in terms of your Riemann sum? So in this case, ibababa mo lang siya. So baba mo lang siya, okay? And then pag na-reach mo yon, so gaganon mo na lang siya kasi we're doing the left endpoint now. Okay? So ito ngayon yung area niya. Okay, so this one is an overestimate. This one wala kang shade kasi 0 siya eh. So, yon. And then for the next one, we have pi over 2. So, pi over 2 is around 1.57. So, if this is, I think this one is 1 unit. This one is 2. So, kung 1.57, around dito ka. Okay? And then, if we're using the left endpoint, so, kailangan mo naman ngayon na tumaas from this curve. So, that is, you just have to meet this point here. Okay? And then, gagawin mo naman is ganyan na siya. Okay? So, ganun naman ang atin for the next rectangle. Okay? So, masyado siyang kulang, no? And then, for the next rectangle, we have 2 pi over 3. So, that is around 2.09. So, if you have 1 here, 2. So, dito lang siya, lalampas lang siya ng konti dito. And then, you project this upward. Okay? So, yun na yun yung atin for the next rectangle. Okay? So, we have 1, 2, 3, 4. So, we still have 2 of them. So, 5 over 6 naman tayo, no? So, pi over 6. 5 pi over 6 is equal to 2.61. So, that is 2. This one is 3. So, dito ka banda sa point na to, no? And then, you have to project that. So, pababa yung ating curve. So, you have to project downwards man dito, no? Okay? So, ganyan lang siya. So, this one is yung, ito na yon, no? So, imimit mo lang siya doon. Okay? So, ito na yon, yung last one pala. So, almost, ano lang siya, pantay lang siya doon sa kanina, no? Okay? Okay, so yan yung Riemann sum niya when we're trying to use your left endpoint. So, hopefully, medyo nakasunod kayo nung sa ating ginawa, no? But anyway, hindi naman talaga sobrang necessary na i-graph nyo siya or what. I'm just showing you how it is, how does it look like kapag tinik natin yung Riemann sums. So anyway, your A sub L would be your delta x. So that is your delta x times f of, so you start with f of 0, and then you add your f of pi over 6, add mo ulit yung f of pi over 3, then yung f of pi over 2, and then your f of 2/3 pi, and then finally your f of 5 over 6 pi. And again, hindi natin sasama yung ating pi. Okay, so with this, your a sub L is equal to pi over 6. Okay, and then you multiply this. So, kung 0 yung sign natin, di ba, alam naman natin, pag 0 natin yung sign, so 0 na to. Okay, kaya nga 0 dito yung area natin eh. So, dito, based on sa area, may makita natin na may mga sagot tayo, so the rest. So, if that's the case, so sa pi over 6, so if you have sign, ang gawin nyo lang is input nyo lang siya sa calculator nyo yung values para madali kayo. Kasi ito naman is napaka simpleng ano lang naman siya, value. So, we have negative 1 over 4 for this. Kaya siya negative kasi kung mapapansin nyo dito, downward siya. So, expect natin na itong dalawang magkasunod is positive. So, plus, so we have pi over 3, yung sunod natin. Okay, so that is negative. So, yung ating sunod is negative square root of 3 over 4. Now, but ito negative pero sa graph ko is positive. So, basically, kung ganito yung nangyari, ibig sabihin nito, na lampas ko yung supposedly dapat units ito. So, halimbawa, the graph looks like this. So, kung halimbawa, ito yung 0 natin, so makes sense. Most probably, nagawa ko is, na-extend ko siya farther dun sa curve. So, supposedly, dapat mga halimbawa, hanggang dito lang siya. Okay? Para pwede mo pa siyang i-connect dito na downwards pa siya. So, most probably, ganun yung nangyari dito. So, it's just that lumampas ako dyan sa, sa pag-drawing niyan. So, gawin natin is i-adjust natin tong drawing, no? Okay, so, i-redraw ko to, okay? So, wait nyo lang.
A few moments later.
Okay, so, I've redrawn the Riemann sum. So, hopefully, mas accurate na to, no? Kasi kanina medyo, kaya iba yon, kaya hindi tayo nagtama kasi mali yung ating nagawang intervals. So, yun yung importante din dito kasi if you're trying to graph that, then kailangan ma-make sure natin na tama yung ating interval. Kasi mahirap pag hindi sobrang accurate. Ayun. So anyway, I'm hoping na this one is already the most accurate I could give. So, we move forward na dun sa ating pi over 3, I think. Hindi. Ano na tayo? Pi over 2. So, if you have x, which is equal to pi over 2, then we have 1. So, we have positive 1. Nandito na ako sa 2/3 pi. So, if it is 2/3 pi, then your value of the function is negative square root of 3 over 4. And then, finally, this 5 over 6 pi would be equal to negative 1/4. So, yun yung ating magiging mga values for this equation. So, by the way, may mali ako dito ng solve, I think. This one is supposed to be over 4. So, kasi 0 yung f of 0, pi over 6 is negative 1/4. So, yung pi over 3 should be negative square root over 4. Kasi kung mapapansin nyo, para siya nagre-reflect eh. From this one, ito yung 1 natin na positive area. And then, ito yung negative square root of 3 over 4. So, ito siya. Saan ba yun? So, ito. Okay, and then ito. So, hindi lang sila talaga pantay, no? Dito sa figure ko, syempre, dinrawing ko lang to eh. But it's kind of, reflecting dun sa ating graph na medyo meron tayong negative dito na 4, okay, and then isang positive, and then merong isang 0 ang area. Okay? So you just have to multiply this by pi over 6, yung sum nila. So you should be able to get your area sub left endpoint, and that is equal to, so I'll just use yung exact sagot, no? So that's 1 minus square root of 3 over 2 pi over 6 times pi over 6 units. So ganito na lang tayo. Ito na lang yung lalagay kong sagot para saktong-sakto. So yung 1 minus square root of 3 over 2, galing yun sa sum nitong lahat, and then times mo lang yung pi over 6. Or you can just use pi, o pwede natin kasi sabihin na pi minus square root of 3 pi all over 12 units squared. So siguro ganun na lang gawin natin, no? Para mas maganda siya. So we have pi, and then minus 3 pi. So ito yun. And then divide by 12. So ito na yung pwede nating area ng left. So basically, kung mapapansin nyo, negative yung ating area kasi majority ng ating is nasa negative side. Okay, so what if we try using your area to the right? So, area right endpoint. So, yung ating left, copyahin na lang natin na that's pi minus square root of 3 pi, and then divided by 12 units squared. Okay. Now, if you try to do yung area ng right natin, so papalitan lang natin tong 0 dito, diba? Kasi hindi siya kasama eh. So, and then this becomes yung A sub R. So, this is A sub R, then F, this becomes F of pi. And then, what happens when you have your F of pi? So, that is sine pi, and then cosine of 4 times pi. So, di ba alam naman natin na if you have your sine pi, this still is 0. So with that being said, kung 0 yon, we still have the same value of your left and right area. So therefore, we could say that area using left endpoint is equal to the area using your right endpoint. And this makes sense because kung mapapansin nyo, if your f of b is equal to f of a, then that means na same lang sila. And if we try to take the average or using the trapezoidal rule, so the idea here is that you should be able to get the same results. So if I try to do the trapezoidal rule here, so unahin natin dito, start from 0, then end up here. So diretso lang to, wala tayong area for the first trapezoid. Okay? And then, again, pag sinabi ng trapezoidal rule, ito yung average lang ng dalawa. And this is how you graph it. You just connect the points. So this one is this one, okay? Then diretso mo lang siya doon. And then I think dito siya sunod. And dito, okay? And then somewhere here. So yung mga pinagko-connect ko lang yung mga endpoints ng ating graph, no? Okay? So we have this, no? By the way, this is your 1, 2, 3. This is your 3, and then you have this 3.14. And by the way, since this is the left endpoint, you still have to connect it somewhere here kasi this is the left endpoint, diba? You still have the right here. So, connect pa siya dito. Kasi if you have to extend this portion using the right endpoint, of course, then ma-extend siya dito. So, yung ating mga trapezoid is ito. Kung mapapansin nyo, yan yung mga trapezoid natin. Okay? So, this one is, alam ba yung trapezoid na itong isang to? So, yan. Okay. And then, this one is, nakaganyan siya. Okay. So, yung ating trapezoidal rule for this case, no? So, ang gawin nyo lang dyan is, So, ito yung pangalawa natin. We have the third. Ito, third. Okay. So, how about yung ating fourth? So, yung fourth kasi natin is combination siya nung left-right natin. So, as well as this one, no? So, hindi natin siya kaya talagang i-draw as trapezoid. So, ito rin, no? So, ganun lang naman siya. And then, finally, that area should be the same for the right and left endpoint. So, yun lang yun. Okay. So, for this, the left and right endpoint is the same. And again, you don't have to draw something like this, no? Kasi, syempre, you have to graph it as accurate as possible. So, you don't have to do this kasi kung mapansin nyo naman, kung alam ko itong paano gawin, just add the intervals, no? Yung norm pala, just add it until you reach the lower and right limits. So, pag nagawa mo yun, substitute mo lang lahat dito and then multiply to the norm, then makukuha mo na yung sagot. This is just done para ma-visualize nyo kung ano yung nangyayari using the Riemann sums. Now, if you ask me what is the real value of this integrand, kasi diba, this could be solved using the definite integral. Now, syempre, kung sosolve natin to ngayon, we have to apply your property kapag meron tayong sin A, cosine B. And then, just to give you an idea kung ano yung magiging sagot dito, if you try to integrate that properly, then I'm not using the Riemann sum na as in definite integration tayo. So, the answer, kakalculate ko na lang, no? So, the exact answer should be around, lagyan natin ito, real answer. Syempre, again, yung Riemann sums kasi, this is a method of approximation. That's why you don't have to expect na yung magiging sagot mo lagi is talagang saktong-sakto dun sa real answer. So, the real answer is negative 2 over 15. So, if we compare this value to the one that we've obtained, so that is pi minus square root of 3 pi. So, I'll try to evaluate it kung anong result. So, this one is approximately equal to negative 0.1917. And then this negative 2 over 15, if we try to transfer this to the decimal form, this is equal to negative 0.133. Okay. Now, this 0.13 compared to 0.19, alam naman natin na hindi siya sobrang layo kasi 0.01 naman yung pagitan nila. Though, if you try to take the percentage difference, I think more than 10% siguro. Let me just check kung ano yung magiging niya, percent error niya if we try to solve for it. So, medyo malaki pala siya, no? Almost 50% deviation siya. So, malaki pala. Pero yun nga, sabi nga natin, ang Riemann sums is just, siya ay approximation method. So, kung malaki man yan, wala tayong magagawa yun eh. And again, the only way to increase your accuracy is to also increase your n. So, if halimbawa, ang n natin is 12, most probably, makukuha natin is less than 10% na agad na accurate dyan. Pero syempre, 90% accurate, ganun. Pero syempre, if we increase the number of partitions, mas hahaba itong ating solution na to. But then again, hindi naman siya sobrang hirap kasi you just have to substitute the values of these, itong mga, dito, mga nakukuha natin dun sa between the upper and lower limits of integration. Okay, so I think that's all for the Riemann sums and we have to proceed na dun sa ating definite integral. Kasi this Riemann sum is parang ito yung introduction sa ating definite integral. Kasi what we have to do is to make this n reach to infinity. And with that being said, instead of drawing rectangles kapag yung n natin is naging infinite, so basically, we're trying to find the area as in the exact area under the curve. So, or above if it's sa taas. So, kung pag-uusapan natin definite integral, so ang hinahanap na nitong definite integral is this area na sinashaden ko, which is exactly the area. So, I hope pag tinanong kayo kung ano yung difference ng Riemann sum sa definite integration, so masasagot nyo na siya in a way na kapag Riemann sum, we're trying to approximate the area using the rectangles, pero pag sinabi nating definite integration, then we're trying to give the accurate area using proper integration and using the general concept of definite integration.